How do we put words into computers? This is one of the most central questions in the field of natural language processing, and the answer goes back almost to the beginning of computers themselves. But there have been some really exciting recent developments in that story that have led to almost a new paradigm in how we do natural language processing. When we talk about artificial intelligence, one of the key faculties that humans have that machines really don't yet have is the ability to understand and use natural language. I believe that if we want to build artificial intelligence that serves human goals, we need for those programs to be able to work with our natural mode of communication, which is, of course, language. Starting in 2018, there were some exciting and surprising findings in the field of natural language processing, most notably the Elmo paper from the Allen Institute for Artificial Intelligence. That set of findings that you could use large amounts of unlabeled data to pre-train a language model and then use the byproducts of that training process in pretty much any kind of NLP system was really exciting. So my goal in this article was to contextualize contextual word vectors by talking about some of the historical developments that brought about this new set of models, new set of approaches, new paradigm, and new advances in the field. Classically, words were represented using discrete representations, which often meant an integer. So what this would involve is taking every word in the vocabulary and mapping it to an arbitrary integer. Discrete word representations don't allow us a way to say that two words are closer or farther apart in meaning. Vectors are a really useful tool for allowing notions of proximity or closeness between word meanings. So if the meaning of a word is a vector, then we can ask what other words are nearby, or what is the relationship between two words as another vector. So if words are vectors, then every time we learn about what one word means, we're actually also learning about what its neighbors mean. For many years, the continuous word representations or word vectors that were in use were associated with word types. So the word apple was associated with a vector, and every time you saw apple in a piece of text, you would use the same vector. It doesn't need to be that way. You can easily imagine having a different vector associated with each token of the word apple. That way, when we have an instance of the word apple referring to the fruit, it can have a very different vector than an instance of apple referring to the company. So word vectors are biased. When we take a large collection of text that emerged from a particular culture, then we fully expect that the word vectors we build out of that corpus are going to reflect those same associations. And so it shouldn't be too surprising that when you look at the word vectors that emerge in a large corpus that's been collected during, say, the 20th century, there are going to be strong associations between, for example, some professions and one gender and other professions and the other gender. There are always going to be these kinds of associations that are unwanted, but by thoughtfully selecting data and diversifying the data sources in ways that work against those associations, I think we can do somewhat better. But this is probably not a problem that will be completely solved anytime soon.